All right, guys, I think we can get started. I want to thank everybody for joining our meetup today. We continue to have our online meetups. Waiting for the day we return back to physical presence, hopefully in the next few months here, but we'll see. But until then, we continue to bring our group together and bring you great speakers and content. And today is no exception. We have our topic today is Serverless in Action, presented by Chad Green. Chad Green is a manager, software developer, architect, community leader, Microsoft MVP, and most importantly, a father and husband. Over his career spanning 3 decades, Chad has managed groups from 3 to 63 people, worked on projects in a wide variety of markets, including education, healthcare, military, government, workforce management, financial services, chemical research, and electronic commerce. Being a big believer in giving back and wanting to ensure there are cool events for others, Chad founded and chairs the annual Code PaLOUsa conference, organizes the Louisville .NET Meetup user group, and the monthly Tech Leader Coffee and Discussion, and has helped other groups like Louisville Tech Ladies and events like Cincy Deliver. Thank you, Chad, for being with us today. Take it away.
Great, thank you so much. Let me share my screen here. I believe it is sharing. Yeah, I see it on the screen there. Okay. So here's just the typical Azure portal. And what I want to do, I just want to quickly show how we create an Azure function. It's pretty much like anything else within Azure. We'll click a add resource. Function apps is one of their bigger products, right? So it's right here. So I can click create. So I don't have to search for it. Make sure I pick my right subscription, and our resource group. And if you're new to Azure Function, or not just Azure Function, but Azure, resource groups is just a way of grouping resources together, hence the name. One of the really nice things, especially when you're doing stuff for maybe a proof of concept, or like in my case, I'm doing a presentation. You see I have the service in action. After tonight, I will just delete that whole resource group, and everything will be just gone, right? I do have to give it a name. There are a couple rules. I think it's 128 characters it can be, and but otherwise we can name it as need be. So we can say Funk Roanoke. And then here you can see we're picking the runtime stack, the language that we're going to be using, right? So we'll do .NET. We're going to pick our version. So you'll notice that within here you actually have to get support if you want something prior to 3x. But we'll just, doesn't really matter, but we'll pick 6 just because. And then the region, right? So again, the idea of having your Azure function as close to your customers as possible. And one of the really nice parts about Azure Functions, because of the fact it is a pay-per-use and all this kind of stuff, I can so much easier set up multiple copies of the same. You can quickly And then actually, we're just going to go ahead, because I created one the other day. So we're just going to go ahead and go into here. But so that's off and running. And like I say, it doesn't take long, but it's running. And so once it's done, you're going to get to something similar to this, right? So here you see your portal. And, if we go to functions, and you'll see I already have a function here, but we'll just go ahead and create a new one. And right away, you can see I can pick how am I going to develop this. We're going to do it in the portal for this first one, just because I want to show you can do this, all right? And we're just going to pick an HTTP trigger, all right? And it's going to give this wonderful name of HTTP trigger 2. So we're going to click create. This will take just a moment. And there we go. So now we're in that function. And what's pretty cool is if we go to code and test, you can see the Azure Function app we were creating is now created. But so here we go. We're in here, and so this is interesting what they've done. This is what they call C# scripting, right? So it's very much like regular C#, right? You see a lot of the structure. One of the big differences is this right here, where you see that R, the $R. That is actually how I add NuGet packages within this, with this C# script. So you can see, they're using the new Newton package on here, but I have my using statements, just like, and everything's the same. So just to show you what this is just a simple hello world. So you can see it's gonna log, that it received a request. It's gonna look. So what it's actually doing, this is you're looking at the query string, right? So it'll actually look for a query string of the name of with the name of name, right? Or it will look for a in the request body. And it'll try to pull it out of the request body, right? So it'll look for both places, does some logic to see if it actually has a name. And all it's going to do is it's just going to generate a response message. Basically, if you didn't get anything, you're going to get this message. If you did pass something, you'll get an OK object. So it'll send back a 200, right? One other thing I wanted to show. No, that was okay. Yeah, that was it for here. So, the other cool part is I can actually, I can get a couple of things. One, there's logs in here. So I can actually see the logs. So like for example, this message will show up down here, right? And any other logs I send here. So the cool part is, there's some more functionality you see on the screen when I'm doing a C# script, as opposed to where I wrote it externally and brought it in. But the logs is one of the things that always does work, which is definitely a good way to debug code. When you're getting weird things happen that, it worked on my machine, but now it's not working in the cloud. So you actually have that ability to do stuff there. We also have this test and run, so, and again, you can see that I can either do a post or a get, right? So, and then you can see it by default created me a body, because it's actually looking, it's inspecting what the thing is doing. So if I just run this, right, it's gonna, and here you're seeing that, talk about it's spinning stuff up. It's called a cold start. Notice it took a moment, right? But it ran. You can see we got our response message back, right? So there's our hello Azure. This is a HTTP trigger function. We got a 200 back. And again, we also see this in here, right? We see that it executed. And actually, you generally get two things, right? You'll see that you'll see that the execution itself, but then you see the message we sent, right? We sent the message out here. Just show you what I was talking about. Notice I took a moment to run this again. Sure, prove me wrong. Take longer. It usually goes quicker than that. It's because I'm demoing. That's why it's going to be slower right now. But again, you see it run again, right? So so that's really nice. If we look at some other things within the portal, just to show you off the portal. Actually, go back here. If we look at monitor, this is really nice to see. To check how many invocations have happened. is delayed a couple minutes. That's the reason why I see it only says one. A couple moments, it'll show that second one, or it should be. Sometimes this is not the most accurate. That's, application insights definitely is better. But it's definitely gives you some nice, easy way. I can also get to my logs from here. Again, just a nice way of seeing that. But then, some other things I wanted to show in here. Number one, is app keys, right? So you'll notice that when I ran that, it was selecting what it called the master key. So I was talking about this earlier. By default, Azure Functions actually requires a key to be passed in. So you have some level of security, even if you don't use, say OAuth or what have you, right? It's actually, you can get some things built in here. And one of the reasons why I show this is you can create new host keys, right? So it's not just the ones that the system created. So like, for example, a lot of times we'll create like a key for Postman to use, right? And, that way all of us know that, the Postman key, and when someone leaves, and we can change in one place, and everyone gets updated, that type of stuff, right? So you can create your keys in there. You actually can specify that Azure function runs anonymously. I generally don't recommend that, right? For obvious reasons, right? Because you are going to pay for every execution. So if someone found your anonymous Azure function, they could run up your bill, right? Although I will say Microsoft does have some tools in place. It is watching for high hit counts, and will actually start throttling, and because it's actually watching for patterns, which is pretty cool what it does. Some other things to talk about within the portal. Number one, next one is deployment slots. So if you've ever done web apps within Azure, very same idea, right? Where I can have these slots. So I'm not going to create one because it does take a moment, and I'm not going to use it. But like for example, I can have that dev or that test slot that I can put stuff in there first, do a smoke test, make sure it works before we actually swap it into the production one. The one limitation that Azure Function has, as opposed to say app service, is you can only have one additional slot. So you 2 slots total, the production slot, and then whatever other slot you want. So that is one limitation here. But generally, that doesn't usually cause me problems, because like I say, with the way how Azure Functions works, I usually have a development Azure Function app and a production development app, right? But like, and actually I only worry about the slots when I get to production. And that's because we'll deploy to production. We'll do we actually automate a smoke test to make sure it did what we think it's going to, make sure it didn't blow up for some crazy reason. And then we'll do that swap. So that's that. One last thing, or 2 last things I want to show. Next one is configuration. It just, again, we can actually set up configurable values. So, I can go in here and say, user group, and we can say Roanoke. And we now have that available for our well, I have to save it, but we have that available for our use. It is interesting the way how Azure Functions does this. When it does this, it actually creates an environmental variable. So in your code, you actually are looking for environmental variable. So you look for the environment variable called user group, and that's how that will get used. Now I will say, I generally recommend, depending on what, how much you're using this, but we will actually use, there's a service called app configuration service, which kind of consolidates your different app configurations into one place. But you can do labels and you can do environments, and, so I do really highly recommend looking at that service. So a lot of times the only app setting we will add here is the URL to our app configuration service. So we can point to that. I'm just going to discard that. Not that it matters if I create it or not. One last thing I was going to show is App Insights. Actually, let me go back one quick second. Let me go back to the functions. I'm just going to copy. It does have a nice way to just get the URL, which includes the key and everything I need. And the reason why I was going to do that, I'm going to go back here, Application Insights. I'm going to go ahead and go in here, and I have, if you've ever looked at Application Insights, it does everything that you expect, right? Your fails, your server response times, all this great stuff that you need. The thing I really find useful, especially when we talk about Azure Functions, is the live metrics, because you can definitely see what's really going on with your server. So I was just going to definitely number one, we can see how many servers it's running at the time and everything. And so sure enough, if I was to just call this right here. So there I called that, and we see it got hit right away. One of the reasons why I liked it, because it's live. I mean, it's only a couple seconds behind, right? So you're definitely getting a true live picture of what's going on. So, all right, so that's the portal. I mean, there's other things within the portal, but that's the main things we really worry about. Let's actually get into where we really start writing some code. So well, I would say, yeah, we see the different, different triggers we can do. And we can pick the different ones. I'm going to do anonymous just so that the URLs look a little bit cleaner. All right. Again, I wouldn't actually do that, in reality. And, we're going to see something that looks very similar to what we just saw, right? Just some slight differences. The code itself is actually the exact same code. The bindings get a little bit different. And that's because the way how it handles, on the portal as opposed to the way how it handles in Visual Studio. Visual Studio is definitely a whole lot nicer the way how bindings happen. So here you see the trigger, right? So I'm doing an HP trigger. You can see I'm defining it as anonymous, a post and a get, so it's allowed either or. I can even define a route, right? We'll see that here in a moment. And then we get an HP request, right? Which allows us to do some nice stuff. The honest truth is this is going to do the exact same thing we just saw, right? So, but just to show that, so you see it popped up a console window. You see, here I get my address. If I didn't have an anonymous, you would actually see it showing the key to run in there. Or no, it doesn't. Never mind. Ignore what I just said there. Because actually, that's right. On local, it starts it up anonymous anyways. All right, that's just by default. All right, so now if I go into Postman and we run this request, again, it's not going to do anything all that fancy here. Let's actually specify this correctly. Name equals Chad, right? So there you go, hello Chad, right? So nothing all that special, right? But the fact is I was able to do this all locally. I get my debug screens right in here. So, this is definitely a really nice way to develop your code. I can generally see that everything works before I deploy it. There are some times where things go a little bit funky when you deploy it, but rarely does it happen. It generally matches pretty darn close to the real scenarios. Couple things to show within the project. One is your local settings. So this is nice. I showed you like the app configuration, within the portal. This is basically the same thing, right? I can have this. The nice part is the get ignore. If you look, if you dig into that, deeply, it is ignoring the local settings file. So I can put passwords in here and not worry about it being checked into GitHub or whatever you're using. So that's really, really nice. So that's, definitely a nice feature there. The other thing in here is the host. Here's where we will end up setting up some options. We're not going to be setting up any options tonight, but you do actually have that ability to make some changes within here. So I mean, again, that's just really simple. Let's actually go into an app. And what I'm gonna do, instead of having you watch me fumble and write code, I'm just gonna go to an app that I fumbled and wrote last night, based off of another app. So it's not like I actually wrote all of this last night. I will say the timer trigger is not working. I'm not sure why, but I can still talk through the code. But what I've done, again, like I said, so I do stream on, well, I haven't streamed in a while. I'm trying to get started back up, but generally I stream on Twitch, do live coding on Twitch. I actually also do a Lego stream, right? So, I build Lego on Twitch. One of the things I wanted for my channels was the ability, like I said, to have random quotes come up from a bank of quotes. And sure enough, there are services that do this even for free. But what's the fun in that, right? I want to write it myself. Plus, it gave me content to do on the stream, right? So that's what we've done here is we've got this random quote bot, right? Now, first what I want to show is this class library. So this isn't in and of itself anything to do with the Azure function, other than the fact the Azure function is using this, all right? In particular, the one that's important is what I call this table services. Not actually a really good name, but in here, I'll make that bigger. We're seeing where it's actually doing a lot of the work, right? So for example, we wanted the ability to have multiple channels to be able to use the service, right? So, have that endpoint, and in here, it's actually doing the logic. I will say there are bindings for the tables, and that's what I'm actually using for storage. I don't find they work very well, so I end up just using the regular SDK, in that scenario. But so I'm doing the code now. Part of the reason why I do this, and one of the big things, one, gives me code reuse, right? Maybe I need an Azure function to do something, but I also need a web application to do something very similar, right? So I can, it gives me the ability to reuse code. But the other thing is Azure Functions does not have a good solution for testing. Now, grant you, what I find is most places aren't very good at testing anyway, so maybe that doesn't matter. But if you want to do unit testing, Azure Functions does not have a good solution for it. And the primary reason is there's actually no good way for the unit test to attach to the Azure function. So generally, the quote unquote documented way to test it is you're actually watching for the input, for the inputs and for the outputs, and then checking that, right? So it's not a true unit test. I mean, number one, at that point, it's actually an integration test, but I'm not able to actually mock anything and that type of stuff. So with here, I don't have unit test on here, but I could actually write full unit tests. That's the big reason why I recommend this. And again, the other part is just keeping that Azure function as small as possible and doing just what it needs to do. All right. So we have that. I mean, there's a couple other classes in here. This is the class that actually does all the work. Most of these are representations of entities that we're using. So if we actually go in here, here we can actually see the stuff. So I will start off with this add channel. So this is, actually before I do that, I want to show dependency injection because it's kind of weird. And I'm actually waiting to see what Microsoft is going to do with dependency injection. So Azure Functions in C# by default doesn't have dependency injection until you add this file. So you have to add the startup class. You have to inherit from function startup, right? And then, but once I've done that, I have the ability to do dependency injection, right? Which obviously, we all know that it's a good way of doing things. It's a common way of doing things. So that's one point. Now it is interesting. In the isolated model, they actually have built-in dependency injection, right? So this other project I have here, this is actually a .NET 5 Azure function, and by default it creates the program, right? And it looks just like how it does in an ASP.NET app, right? You have the host builder and all that type of stuff, but so it's actually ingrained a little bit more. So I was really hoping to see that with .NET 6, but that's not what they've done, at least so far, right? Who knows? Maybe I know they're going to be making some updates, but that, as right now, there's that division there. But anyway, I've created my dependency injection, so I'm injecting this into my functions. So now, if I go into the function, I will say, you will do, from your menu, there is the add new Azure function, and this works just like what we just saw. If I just accept the name again, I pick the trigger I want to do. I will say this: it does write boilerplate code. It's just a class file, though. I mean, so you don't actually have to do that. You could just do a regular class file and write all your code. All depends on what works best for you. And that's why you see, now I will say by default, they make their classes static and the methods are static, which makes sense. There's actually some good performance reasons for doing that. But if I want to, obviously if I want to do dependency injection, I can't use static, right? Because I need reference within the class. So, I've taken the static attributes off, and then I've, created my constructor to take in, what I needed. And here, so this is a very simple, it's again, just an HTTP trigger. Notice that now I'm only allowing post, right? So I'm following, typical REST patterns, right? So you do a post, you'll send it to, here you can see my route, right? And when I run this, you'll see that how it takes that route and builds the URL correctly. And then when I put it in the curly braces, that defines a parameter, right? So, I'm saying it's going to be in channels and the channel name. Everything else is the same, HTTP request. The other interesting part is you then add in, your parameters. That's how your code knows how to read that. So, and in here, I'm not really doing anything all that special. I'm going to here. I'm going to grab I'm going to deserialize from the body. I just put it all in one line. Right? So it's going to do a stream reader against the body because it comes as a stream. And a lot of times what I'll do is I'll override, if the channel name was provided, I'll generally override it because, again, following the REST patterns. And in here, I'm just calling add channel, and you'll see the add channel actually returns we look back at that, it's going to return. So you call the table client, I'm calling upsert entity. It returns a response. Within the response, there is status, which is just an integer, which is the integer value of the HTTP status, right? So I'm actually able to just use that. I return a new status code result, and there you go, right? And so it does what you want to do it. And you can see a little bit of error handling here, right? And here you can see I'm just returning a 500. So if I was to run this now I have other functions in here also, but that's fine. But we can go in here. And again, so you see that the structure is getting created here, right? So we can say add a channel. and we'll just say code for the channel. Go into our body, raw JSON. I actually should have done this beforehand. But like I actually need to look again. Hold on a second. I forget what we need. We're going to do channel name, although this actually gets overridden, so you don't really need it. And then message frequency. I just have to make sure I spell it right. And then this is the number of minutes in between sending the messages, right? We start that back up. And sure enough, if we go back to Postman, we run this, and I got a 404. Why did I get a 404?
You stopped the debugging.
I did a get. That's the reason why. I forgot to change the method. Now, if I run this, you'll see I got a 204. I apologize. This is as big as I can't make Postman bigger. But I got a 204 back. And sure enough, if we go back to the portal real quick, we can, and we go to the storage account, just to prove that it actually did something. There you go. You can see that it created that row, right? So I now have that row ready to go. So just getting through some of this other code here real quick, just kind of show it all working, or what it's all doing, and show some more of the bindings is what I want to show. So that was add channel. If we look at add quote, right? So add a quote for the channel to be served, right? So pretty simple what this is going to do. So again, it's not actually, I just remember, this isn't going to do anything special, right? It's just going to do the exact same thing, right? I forget, it's the next one where I actually do the bindings. So let me add some quotes in there real quick. So if we go back to Postman and just say quotes, and this one, I do have some JSON ready to go. So, we can add this quote here. A day not writing JavaScript is a good day. That's a motto I live by. Oh, I got 500. Oh, I know one. I shouldn't give it. Well, it would help if I properly formatted my JSON. There we go. We got that. I'm going to add just a couple more real quick. Although I got to fix my JSON. So we'll have that. I'm going to do one more. All right. So just adding some quotes in there. All right. Now let's go back to the code and look at the next one, because now we need that in there to get this to work. So the here we're seeing the actually I wanted the get quote. No, that's the one I want. Get random quote. So in here we start seeing where we're actually doing a binding, right? So we already had the trigger. The trigger is exact same, it's just a different route. But now you can see I'm doing a blob trigger. I'm sorry, a blob binding. In here you provided the name of the container, and then actually I'm sorry, this is the name of the blob it's going to create. And so I'm this is the way how I'm doing code IDs and channel name. That gives me a way to separate them. I'm actually reading this, so you can see it's going to do a read, and it's then pointing to my connector string. And that is, if I was open up my local settings, you would see all those in there. I'm not opening up because I actually have my Twitch subscription key in there, and I don't want to show that. But it's in there. So, and then what's cool about this is it's going to give me a stream, right? And I can just read that stream as just like I did before, right? So so that just works the way how it always would work. What I wanted to show real quick. That's right. I think I showed the wrong thing when I was talking about the add quote. I think I was showing get quote. Because here we see an input and an output, right? That's what I just wanted to show. And what's really cool about this output, and basically what I'm doing is, the quickest way to figure out what, so table storage doesn't have like an auto incremental ID, right? So what I'm doing is I'm storing in a blob. I'm just storing the max ID, and then, so I'll go in blob, go get the next value and save it, right? And that's what we're doing here, right? So we'll get it and then we'll save it, right? Oops. And what's really cool about this, if we look at the right quote ID, there it is. All I had to do, so what I said was, okay, if I got back a 204, all right, so basically it successfully wrote that record. I'm just going to do it right. And here, I'm doing I have to encode it because it's a blob, right? But that's pretty simple. I didn't have to connect to it. I didn't have to write the client or all that type of stuff. And the cool part, actually, this is one of the harder ones, right? Like, for example, the Cosmos trigger. If I do a Cosmos output trigger, I literally just write to an object, and it saves everything for me. It does all the logic it needs to do that save, right? So it's really nice to make that work. So again, if we just want to see this all working, so I'll start this back up. If I do the get random quote, and go back to Postman, and I give it my channel name, and now I can run this, and there you go. So I got a random quote, right? If I run this again, I'll get another random quote, and I'll So again, it didn't take a whole lot of work. I grant you, I copied very heavily from something that is running in production right now, but I actually wrote all this code last night, in a couple hours, right? And I reformatted some of the stuff, right? Just because some things have changed since I originally wrote that stuff, just to make it better. So again, I think it's where we're showing just how easy Azure Functions can be. One last thing we'll show in the code before I leave. Just something you can do, and again, things are a little bit different. And why I like the isolated versions better is you'll notice that this is using a request data instead, and it returns back a response data. And these are newer objects that actually have more power to them. So you'll notice now this is actually an extended method, this get request parameters. Actually, you can get it on Taylor and Code on GitHub on my Taylor and Code channel. And it actually will, it'll actually parse the request body for that object, right? So you can see, obviously I'm writing a lot of code with this, so I'm, but also like I get a create response. Things just work a lot easier with this. But the older way of doing Azure Functions, it's still the current way, but some of the newer stuff is definitely giving me even more power. The last step I want to talk real quick is best practices. Just go through this real quickly because I think I'm running out of time here. There are three quote unquote absolute minimum best practices. One, should do one thing. You notice in that quote system, everything was just doing one thing. It was just writing a channel. It was just adding a quote. It was just getting a quote, right? I'm granted it's a very simplified example, but the point was we do just one thing. Next, it should be, and I have a hard time saying this word, idempotent. All right. So basically every time I hit it, it should do the same thing. All right. Now, grant you, like in the random quote, it's going to get me a different thing, but that's, but it's still returning me the same type of data every single time. All right. It should be very consistent in what it does. And it should finish as quickly as possible. All right. And one of the biggest reasons is because you pay for execution time. All right. So, you obviously, you definitely want to make sure that, in order to keep your costs down, you want it to finish as soon as possible. And with that being said, on the consumption plan, by default, it's limited to 5 minutes. It will time out if it runs more than 5 minutes. Excuse me. And the max you actually can change that, but the max you can set it to is 10 minutes. Right. So now, if you run it on app service plan, it can run for as long. It could run for days. Right now, that'd be kind of crazy. Be kind of curious what you're doing with that. But the point is, you could do that. And that's what the slide's saying. You could use the app service plan. Technically, they say durable functions for longer running functions. I think it's kind of a little weird because these aren't really running for 10 minutes. Generally, it's generally workflows. But point is you have that ability. Some other general best practices. Again, those long running functions. And, because again, it really will cause issues. It will, and refactor these into smaller functions. You'll get better results in the long run. One thing you want to avoid is cross-function communications. So having function A call function B that calls function C and so on, right? Actually, Azure Functions handles it just fine. The issue you have with it is function A is still running while it's calling function B. And if that calls function C, function A is running all that whole time, right? So, you're going to get something that you're not expecting, right? So you definitely want to avoid that. Plus, there can be some issues in the way how the instances get recreated. write your functions to be stateless. Just it's just a really good practice. And with that, be idempotent, right? Have it always do the same thing. Have your functions be defensive, right? I mean, this is general good practice, anyways. But especially when you talk about something where Azure functions that are getting fired so often and so quickly, you want to make sure they're being defensive. Especially when we think about the idempotent, right? Type of stuff. So definitely be very defensive in the way how you write stuff. Definitely do those try catch boxes. Catch what look what you're looking for and so forth. Do not mix test and production. I see this every once in a while. They'll mix it all in the same stuff. And the biggest issue is memory allocations, because obviously in your test stuff you don't have everything tied up together. And this is so easy to do, right? To have one Azure function app that's running multiple things. Definitely split those out. Use async code, but avoid blocking calls. That kind of goes without saying with async. But definitely it's even more compounded when we talk about Azure functions. Receive batches or messages in batches, right? So in the examples I was showing, I was just sending one message at a time, and actually that use case makes more sense with that. But one of the things that I had a team working on recently was an upload procedure, right? So customer could upload sets of data, right? And we actually had it so it was doing a batch and then parsing out, right? And it worked a whole lot quicker that way. And again, making the Azure function be as efficient as possible. And as far as how to get how to get started, start small, right? Pick something small. Do one API, one background process. I mean, that's actually the way how I got in Azure Functions was I needed something that would, every day go to an FTP site, download this file. It wasn't even that big, right? And then do a quick little parsing with it, right? And I found Azure Functions and, did a timer trigger, and it really made my life so much easier just with that one. And integration is a great way to start, right? Building a new layer on top of old layers, right? You'll get a lot of bang for the buck on that one. So that's what I had in a nutshell. Again, there is all my contact information. Definitely, if afterwards you think about something that you didn't think about now, I'll be sticking around here for questions afterwards. But that's what my contact information. Or you want to ask about other Azure stuff or architecture stuff. I mean, that's why I put all that contact information up there. And again, thank you for having me.
Thank you, Chad. Let's see. Anybody have any questions you guys want to bring up?
I just had one aside question. You mentioned you used a preview version of 2022 Visual Studio.
Mm-hmm.
You found it to be pretty stable?
Yes, I've had no issues with stability. It's actually been the best one I've seen, for stability, even compared to 2019 preview that, in the whole time it was just doing updates. So I've been running preview versions for years. But yeah, 2022 is definitely a whole lot better when it comes to that.
Okay, I was considering switching to try it, and I didn't want to try it if it was buggy.
Yeah, and it's got some really nice features that make writing code so much easier, right? I didn't use it tonight, but I wrote another piece of code. I wrote was actually a C# app that called the Azure function, right, using HTTP client, and it actually wrote most of my code for me.
Oh.
I literally click enter and it wrote the next line. I'm like, oh my goodness. Okay. It was actually kind of scary how smart it was on knowing what to put in there.
Okay, I'll give it a shot then. Thank you.
Let's see, I have one question. Do you have any recommendations around how to deal with cold starts? I know we use AWS Lambda functions a lot, and we still experience issues with when using it as an API background for applications.
AWS is definitely better when it comes to cold starts. There is no doubt about that. Now, with that being said, you can go to the premium plan, right? And because that's one of the things they get rid of is there are no cold starts. Your function's always running. Now the thing is you're also always paying a minimum of $150 a month, right? So you're paying for that ability. So there's that. What I actually do is I actually have another Azure function that runs on a timer, and every 15 minutes it calls the endpoints I need to keep warm.
That's exactly.
It's a whole lot cheaper to do that than to do in premium, and that's actually what we're doing right now.
That's
so we actually we have we store the endpoints we need to hit in a table storage, and actually right now we got it running every 5 minutes. We're about to scale that back down, but to every 15 minutes. But every 5 minutes it's running, and it's keeping because I've got several Azure functions that are brand new, and the customers are just starting to use. and I don't need, and it's for marketing websites, right? So I don't want I mean, every once in a while it'll take like 14 seconds for it to start. It's not doing that much, right?
The ones that aren't used often is the worst, right? Because they get
exactly.
Dead,
so now the funny part is once this customer actually starts using it, it's a marketing website. It's going to be used not 24/7, but probably 20 hours out of the day, right? So it's it's going to be constantly hit. But right now, but what I don't want right now, because it's an important customer, I don't want them thinking, oh, well, I went out there and it took 14 seconds. This is for a marketing website. That's horrible, right?
Nice.
Because in reality, it takes 50 milliseconds, right? When it's warm.
Hey, Chad, I have a question. First of all, I appreciate the talk tonight. It's really interesting. But on the specific use case of web APIs, a REST API, I'm wondering, I don't know, do you have some thoughts about just implementing a REST API using Azure Functions versus, say, an Azure App Service? And secondly, if you do use functions, do you put it behind an API management instance, or do you just?
Yeah. So, well, I mean, I've been doing this for a while, but one of the things that I've got a team working on is what we call we're calling it the Glennis API, but it's the external API, right? So it's not the API our apps are using; it's the APIs that we're providing for customers to provide, to do data uploads, because we don't, we sell different products, and not everyone buys all our products, right? And that's because maybe they have their data, HR data in PeopleSoft and that type of stuff. So that's exactly what we're doing. All the CRUD operations and all that's actually all Azure Functions. And it's all implementing, pure REST, right? So it's, doing the whole RESTful operations and status codes and all that type of stuff. And then I have API management in front of that. So the customer doesn't actually know that they're calling an Azure function. They're calling an API management, which then gives me a lot of other benefits, right? I can we're not doing throttling right now, but we could throttle. But also the really nice part is it gives that developer portal. So I don't have to write more documentation. The documentation comes from, the Swagger that gets built, or we're not supposed to call Swagger anymore, the open API that gets built automatically.
So the decision to use functions as opposed to Azure App Service, was that a cost decision, or was there some other factor that made you go that way?
It was most of a cost decision. Now the thing is so we're doing both, right? So our actual applications are using web APIs. And so that's, and one, because it keeps, because the same developers that are building the APIs are building the web screens, right? So it kind of keeps them in the same flow, right? It's still controllers, and it's just a different type of controller, right? So that's the primary reason for doing that. And then the Azure function, the big reason is because the app, I have a better idea of the use, right? Because it's pretty standard during the business day, because most of our apps are used by business, people working in the office, right? So it's a standard, time of the frame. We have a couple of apps that are used 24/7, but most of them are used during normal business hours. Whereas when we talk about the functions, I could have a customer that all of a sudden needs to send me a whole bunch of data. And again, I don't want to have servers just waiting, again, paying for servers that, not going to get, constant use. And that's one of the great parts about serverless is that it'll just spin it up for me automatically, and more importantly, spin it back down when it's done.
Okay, great, thanks.
Mm-hmm. And I will say, outside of cold starts, right, which, like I said, I've done the warm up, so it keeps them warm. A customer does not notice the Azure function or AWS Lambdas and so forth. You don't notice the service spinning up more instances of itself. I've done some testing. Actually, it's kind of funny. I was going to do a demo of it tonight, but my demo doesn't work very well anymore. I used to do a demo where I would just hit an Azure function repeatedly, and it was really cool because within 2 minutes, you would see it go from 1 server to 5 servers, but it never slowed down. It never, and what was cool, what it would do is the first server would be spun up. And then when it got to about 30 to 40% utilization, it would spin up the second one. And actually part of that, because there is a little bit of time it takes to spin up that second one. But the way how they've done it is the ones after the second one take no time for it to spin up, because it's actually already spinning up a third and a fourth and however it's already spinning up that next one. And it actually gets to the point that, until it stabilizes, it's running like 5 to 10% utilization and spinning up another server. And within like 3 minutes of doing this demo, it was spin up 5 servers, and it's just all running about 5% utilization. All right. Funny part is, Microsoft's actually done some performance work on it. I can't get it to spin up another server right now doing that test. It was handling, and it was only running at like 15%. So I need to change that demo to actually do something harder so that it actually will tax the server more. But doing just a simple hello world was not fun. Within 90 seconds, I called it 3,000 times. And it was, like I said, it was 15 to 20% utilization.
I guess it makes sense. I mean, if a server is powerful enough to, field the requests, if your request isn't doing that much, why spin up another server if you don't need it?
Yep.
That's cool.
I mean, I did do, because I was playing around how I could quickly still do that demo, and I put sleeps in the function code, right? So we just sleep for 5 seconds, and that worked. It did spin up the servers. The reason why I didn't show that demo, because it also the intrusion detection fired off, and so it started throttling, right? And like I said, Microsoft is, they're doing, they're putting some intelligence behind there. They're actually watching patterns. And like, all of a sudden, you just all of a sudden call this thing like crazy, and it's taking 5 seconds every time to run this thing.
What's this one client DOSing the API? Yeah, nice. That makes sense. That's awesome. Well, thank you very much, Chad. Really appreciate you joining us and enlightening us with your immense wealth of knowledge. This was really insightful, and you went into a lot, and I found it very, very helpful. So thank you very much, and I'm sure everybody else did as well. Next month, get ready for a fantastic follow-up, Saving Your Wallet from the Cloud, presented by Kevin Fiesel. Come learn how all the serverless functions Chad showed us tonight and all the other resources, cloud resources you could be running, do not make you go broke. So make sure you check that out first Thursday of next month.
Awesome.
All right, that's it.
Thank you.
Thank you, everybody.
See y'all.
Bye-bye.